Den som ska... Den, ja. Tack så mycket. Snällt. Då ska vi se. Jag tycker det här låter ganska bra. Låter högt och tydligt. Och nu funkar vår andra högtalare också. Varsågod.
Ska vi stoppa den först?
Men, förlåt mig.
Så här.
De här ska hänga på öronen.
Är det så? Aha, okej.
Känns det okej?
Det är okej för mig.
Ska jag sänka ljudet eller hur känns det?
Om jag vill stänga av den.
Då stänger du av här.
Ska jag prata test?
Så gör vi så. Som pratar du nu.
Test? Ja, bättre. Okej.
Så då kan du göra det väldigt fort.
Så här.
Och så ska vi se om den här hörs också. Jajamän. Det lät det bra. Det kanske lät lite lågt för den här. Han är lite lägre. Oj, gick det bra? Bra. Bra. Då har vi det. Ja, däremot om man stänger av den här själv, då kan vi få myrornas krig i högtalarna. Jag ska inte. Nej, låt den vara. Yes. Lägg ner den någonstans, lite försiktigt och sen bara. Den kommer inte för utan du måste ha den här uppe för att det ska kunna höras något ljud. Och en annan sak då, om sändaren och mottagaren är för nära varandra, då kan de här tappa kontakt och så börjar den här ta in en fax istället. Så har vi en faxsignal, en galopperande häst.
Jag ska hålla mig lite borta från det skåpet eller?
Annars... Om du har möjlighet att röra dig lite åt det hållet någon gång då och då så är det jättebra.
Okej, jag försöker.
Så blir det jättebra. I alla fall. Det som
Alltså jag kan också hänga den på den där sidan, då är det lite längre borta kanske. Vi ger oss ett par centimeter åtminstone.
En annan sak då, när vi kör ut mot YouTube. När vi börjar presentationen med att visa hela det här. Så det här är vad de kommer att se utåt.
Mm-hmm.
Så du försvinner ju här nu när du står där. Men kommer du ut här och står här vid sidan och här, då syns du.
Men den här vinkeln kan inte påverkas?
Ja, det kan vi göra så här.
Alltså, okej. Då kanske... Ja, precis. Alltså att jag åtminstone... Också när jag står här, att jag är mitt i bilden åtminstone. Ja, precis. Ja, så är perfekt.
Bra, då kör vi så. Mm-hmm. Bra, tack för att du sa till. Det vi kommer göra då under det, när du presenterar, när vi går över till din presentation, det är att vi kommer visa det som är på skärmen här uppe. Och sen kommer du hamna i en liten ruta där uppe.
Mm-hmm.
Så det här kommer visas på stora delen och sen den här. Och sen
bra.
I slutet när vi tar frågor och så, går vi tillbaka till den här biten.
Okej,
så det
bra.
är så som är planen. Ja, men om jag är bra. Och så är det jag som håller bort den. Yes, så jag ska försöka komma ihåg att det kan ju komma frågor. Kolla där. Ja, det blir bra. Just nu har vi inget ljud alls. Nej, jag har tagit ner Så. Då ska vi se om jag har ljud. Hallå allihopa! Välkomna till Goto 10. Mitt namn är Mikaela. Jag jobbar här på Goto 10. Håller dörrarna öppna. Och ser till så att ställen inte rasar samman. Hur många har varit här tidigare? Och hur många är helt nya? Yay! Vi har nya människor här. Välkomna. Och ni också som har varit här tidigare, välkomna tillbaka. Goto 10 är ett coworking-ställe där man kan komma och sätta sig och jobba helt enkelt och knyta nya kontakter. Gå på fantastiska event som skapas av bland annat Linköping Science Park. Det drivs av Internetstiftelsen som får in pengar ifrån domännamnen.se och .nu. Så ni som har en sån hemsida eller jobbar för ett sånt företag som har en sån hemsida, det är så ni betalar för det här faktiskt. Pengarna går till bland annat forskning och utbildning för allt som har med internet att göra. Och även då driver de här ställena finns i Stockholm, Malmö och här i Linköping. And I should say this in English. I remember this right now. I'm so sorry. Who's here in English? Who needs English? Okay, I'm gonna take it again. I'm sorry. I'm a human being. We're all human beings. We'll do this. Okay, so welcome to Goto 10. I presume you understood the first things I said about who's been here before and everything. Okay, good. So we're a co-working space. You can come here, you can work, you can hang out, you can develop connections with people. It is owned by Internetstiftelsen, and Internetstiftelsen owns the domain for .se and .nu. And that is how we pay for all of this. We also pay for research and education within everything internet. You can find Goto 10 in Stockholm, Malmö, and here in Linköping. It is free to join. It is free to use. Everything here is free. You can have a pod studio if you want to create a podcast. That's what it's called. Or if you want to use one of our conference room, or if you want to use the more open space and have a conference, we can work together. Do this. I'm gonna pass over to Julia from Linköping Science Park. Thank you so much for your patience.
So, hello and welcome everyone. My name is Julia Bergman and I work as communications officer at Linköping Science Park. And today's event is Tech Tuesday. And Tech Tuesday is arranged by 5 companies, Sectra, Ericsson, Combitech, SIC and NIRA Dynamics. And today's host is actually NIRA Dynamics with Jörg Strömhovel, who will talk about sustainable vehicle safety and efficiency. And if I understood it right, it's okay to ask questions along the way, and we will also have some time for questions afterwards. So, with that being said, take it away, Jörg.
Okay, can you hear me? Yeah, good. Okay, as you said, my name is Jörg Strömhovel. I've been with NIRA for next year 20 years exactly. So when I joined that company, it was slightly smaller, only 15 guys, and with a former bunker or the protection room as a garage. So we have grown since then by factor 10. And I'm originally a mechanical engineer, so a petrol head, if you can call it that way. Not much in software, electronics and all that stuff. But I realized quite fast in the vehicle industry that the bits and bytes are basically where the music is playing, and I will expand a little on that, especially in the vehicle industry. Is somebody else here? I mean, apart from a few colleagues I see here in the public, also good connections to the vehicle industry. Okay, slightly. Okay, maybe then you can learn something today about the challenges in the vehicle industry. Yeah, so for those who are not that familiar with NIRA Dynamics, we have been a very small company. Now we are, I would say, a medium-sized company with about 130. I think we are closer to 150 employees. The company was founded in 2001 as a spin-off here from Linköping University. Fredrik Gustafsson might be a name you know from the university here. He was one of the founders. And what we do is everything but hardware. We only do software. And what our specialty is virtual sensors, signal processing, of course, with Fredrik Gustafsson and the university here. When I joined the company, I came from the Volkswagen Group, who now also owns the company to 100% through their daughter Cariat, Car, IM Digital. That's basically, since a few years, the software branch of the Volkswagen Group, trying to create operating systems for the vehicles and basically the software backbone for the future of vehicles. And we are owned by them by 100%. But we are not working only for them. We have also a lot of customers outside the Volkswagen Group. To name a few, it's Renault, Volvo cars, Chinese ones like BYD, you might have heard of them. Stellantis, the whole group with the brands Fiat, PSA, Peugeot, and so on and so on. So we are active worldwide in the vehicle industry. Also trying to get a little into the heavy commercial vehicles right now, but that's a different topic. And just financially, we are about 30 million euros turnover every year. And what we are especially proud of is that there are more than 100 million vehicles out there running with our software. Most of them with the tire pressure monitoring system, but we also have now more than 2 million vehicles which are connected, which basically collect information about the roads and then transfer that information up to the cloud, where we can then generate maps about the road roughness, about current friction and road damages and all that stuff, and then try to build business models and that based on this data, or sell this data and then create business with that. I will come back to that a little later as well. So please interrupt me, ask questions as soon as they arise. Yes, go ahead.
What's interesting about the 2 million is that they're pretty low comparison. Is that to the 100 million?
Yeah.
Is this something recently that you've been collecting more data? And,
Yes.
Are you going to talk more about it in the presentation? Or this is interesting. Why are you doing it right now? How are you doing it?
We should probably come back with a special issue on exactly that topic, because that is not the central topic of today. But if there's interest, I can assure you we can also fill such a session with that. But to answer your question, basically these are the 5 main products we have right now, and I'm a product manager for the tire pressure indicator and the loose wheel indicator, and I have also a little reinforcement here with the software architect Erik for these 2 products, but also then the mastermind behind the loose wheel indicator, and we have also our head of development here. So if you have really detailed questions, I myself as a mechanical engineer may be unable to answer. We have a few guys here who might be able. But coming back to your question, when we started business in 2008, most of the vehicles were not connected yet. So we basically had only these embedded functions like tire pressure indicator, and then a few years later also loose wheel indicator. But it's only since most of the, or all new vehicles are in some way connected through the e-call, for example, you have the possibility to collect the data from the vehicles and then expand on that. And only since, I mean, we started quite early, and we still, in Europe, we have a good coverage with 2 million vehicles running around, but in the US it's only a few 100,000. So you have a lot of gaps. So depending on what you want to do with the data, you might not have the coverage you need. But it's increasing, it's getting better. Okay, engineers, especially engineers, mechanical engineers like me. If you want to measure something, well, you put a sensor in it, right? You have to measure it, you need a sensor. Very straightforward. So I remember many years ago when I was working for a vehicle manufacturer in Germany, we had I was in charge also of innovative brake systems, brake-by-wire. And of course, brake-by-wire, you might understand it. If there's no mechanical connection between the brake pedal and the brakes, you need sensors, safety-critical sensors, sensing how much the driver wants to brake, and then some software and actuators translating that into brakes. So we had a meeting and we basically drifted away a little from the central topic and realized, well, the ambient temperature, how many sensors for this do we have in an average car? So there was one in the climate control, ambient temperature measurement. Another one in the instrument cluster for displaying the ambient temperature to the driver and also lighting this small lamp if it gets colder than 3 or 4 degrees. Oh, it could be slippery. And then there was another one, of course, in the engine to determine the air density, which is depending on the air temperature, to exactly inject the right amount of fuel. So these were only 3, and we were suspicious that there might be more. And all of them measuring the same thing. And all of them needing energy, needing cable, need mounting, spare part numbers, logistics, suppliers, purchasing, quality control, and so on and so on. So completely ridiculous. So of course, an alternative would have been to do this, to summarize all the requirements you have on ambient temperature measurements. Maybe if it's safety critical, for example, you need a redundant sensor, or you need a certain accuracy in a certain temperature range, or you need other requirements. Why not have only one sensor, which meets all the requirements, one to rule them all, and then maybe put a little smart software, maybe from us, into the vehicle. And then what you would save, of course, is weight. Because this one sensor is much lighter than all the others together, especially with the cables, the connectors, and everything which can break. It would save you a lot of money. Not only as the part itself, but also you need mounting or assembly time, and all the factors I just mentioned. And you would also reduce complexity, because you basically have, instead of 3, 4, 5 parts, only one. Much easier to handle. And you see it here. This is a symbol for the supply chain. I think most of you know what that is. That's a big ship which got stuck in the Suez Canal. And if you have your sensors, 2 containers with that, supplying them, well, you have a problem. You can't build cars. And the more you have, the higher the risk that one of them is missing. So if you only have one, for example, and source it from different suppliers in different places in the world, you're much safer. Which is, of course, a good strategy. And that was also one of the topics here, sustainability. You don't have to manufacture this. You don't need raw materials. You can reduce the weight, means also you need less energy to drive the car, and so on and so on. And also you don't create electronic waste, for example, which you have to dispose of later on. So it's much more sustainable to replace hardware with software. And you can even go one step beyond, and that's basically what we did since 2008. Because our tire pressure indicator is a so-called indirect tire pressure monitoring system. Indirect because there are no sensors in the wheels actually measuring the pressure or the temperature as well. It's just an algorithm which uses existing sensor signals to estimate the tire pressure, or especially changes in the tire pressure. So you tell the system, okay, now you have checked the tire pressure, this is how it looks when it's good. When you're driving then, it learns some data, and then it compares continuously whether there are characteristic changes in the sensor signals indicating a tire pressure change or drop. And that's basically a little anecdote also. When I was working for this vehicle manufacturer, and they had bought NIRA Dynamics and were looking for somebody going there to coordinate the cooperation. And they told me, yeah, they do a little crazy stuff. I mean, they measure the tire pressure, not with sensors, but with estimating the oscillations of the tire. And I said, what? Okay, that's a little strange. That must be magic. So I was really thrilled, because I was also specializing during my university time a little in mechanical oscillations. So I thought this is really at the point of where electronics meet mechanics at its best. And well, yeah, basically they sent me then to Sweden for 2 years. Then we prolonged to 4 years, 5 years, and then I had to make a decision. Do I go back? And that was 15 years ago. I'm still here. So it was quite fascinating. But coming back to this, I mean, if you measure the tire pressure with sensors, you need these sensors, each of them weighing about 35 grams. And you see here, there's a battery. it's not replaceable. You can't open it, it's sealed. That means if the battery is out of energy, you need a completely new sensor. That means also here in Sweden, if you, for example, have a set of summer and winter wheels, you need not only 4 of them, you need 8. And then they also do not last forever. 6, 7 years if you're lucky. In the worst case, you have to replace them. That would mean then even that you need 8 of them over the lifetime of the vehicle. We have now calculated with just 6. That means we have, just with our software, replaced 600 million of these sensors. They didn't have to be produced, they didn't have to be transported, and that corresponds to the weights of 2 Eiffel Towers in electronic waste. And I think that's something which is quite good. And that's not even taking into account the transport, the production, and then also the disposal of this. Because we all know, I mean, if you talk to the manufacturers of these sensors, they say, oh yeah, we take them back if they come to us. But the thing is, they never come back to them. They end up in India somewhere, or China, or in Africa, somewhere in the environment, and that's not really good. Yeah, but tire pressure monitoring systems have also developed over time quite a bit. When I joined the company, this is what we did. Do you know what this light means? I think so. Low tire pressure. Okay, but in our software, basically, it did light this lamp, or it did not. So it's probably one of the most boring systems in the vehicle. Especially, also, it never comes with good news. But 2 years ago, we started thinking, okay, is that really what a consumer wants? Is that really living up to the expectations people have to modern cars? And the answer is definitely no. Because for tire pressure monitoring systems, you have basically 2 main use cases. One is, of course, yes, tell me if I have a puncture or the tire pressure is too low, and otherwise shut up. And the other use case is definitely, well, from time to time, I have to check the tire pressure. But do I really have to go to a filling station? It's raining, it's blowing, I have to go outside the car, then I have to touch these dirty valve caps, screw them off, put something on, I get dirty fingers, I lose time, it's inconvenient. It's much more convenient to be able to push a button in the vehicle or to tell my vehicle, please show me the tire pressure, and then it shows you the status. And that's what the sensor-based systems always have done, and we said, well, we have developed our system so much that we can do this as well now. So we can now display here the percentage figures, for example, or we put out a signal which then enables the vehicle manufacturer to display this. And then you see, okay, the tire pressures are okay. I don't have to stop and check and get the fingers dirty. Everything's fine. Of course, the system can do much more than that. So we have a few other functions as well, but we are far beyond the stupid lamp by now. And now coming back to what you can extract, basically. I mean, what we do with TPI, we have extracted the wheel speed signals, the relative speeds between the wheels with tiny differences being characteristic and dependent on the tire pressure. Also the oscillations of the tire we extract through a frequency analysis of the wheel speed signals, which are also some of them at least are highly pressure dependent. So that's basically the magic which also has drawn me to NIRA. But there's more, and this is basically what you see here. Any idea? Expect you, Ulle, what that is? Yes? Exactly, right on spot. That is a or 2 spectrograms of the wheel speed signals. And the left-hand diagram here you see is if the wheels are properly fixed, properly mounted, the bolts are adjusted correctly. And this is how it looks like if the wheel bolts are a little loose. If there's a certain small gap already between the rim and the hub, and the tire starts to oscillate a little freely, indicating that if you continue driving like this, in 5 to 10 minutes you will lose the wheel. And what we can see with the human eye here, these stripes, well, guys like this, they can also program algorithms detecting this. And also detecting this and separating it from other phenomena like rough roads, cobblestone, potholes. and maybe either also other phenomena like snow chains or severely unbalanced wheels. That looks differently. So we think this is a technology which will be extremely useful when it comes also to condition monitoring and predictive maintenance. Because, I mean, that's basically what we do. What we do with the tire pressure, that's also some, first it's textbook condition monitoring, because you monitor the tire pressure condition, but it's also predictive maintenance, because it says, yeah, well, if you continue driving with this low tire pressure, your tires will be worn out in 5,000 kilometers, and then you will have to buy new ones. So this is basically what we have been doing already since decades. And now we try to expand that space with the tools and technology we have already at hand. And this is basically what we show to potential customers in our demo cars. And you see here, that's a kind of overview menu, a pre-flight check if you have a pilot's license or have looked into a cockpit before the flight. They go the checklist and check all the technical systems. See here, all monitored components okay, no action required. And this is basically the components we have, or we hope to have in a short time. Tire pressure, the wheel bolts, I mentioned that, that's TPI and LWI. We have also a very good prototype regarding tread depth, able to follow the tread depth plus minus 1 millimeter, also tire individually. We have a very promising investigation about worn out dampers, that we can detect them also without any additional sensors, just doing smart analysis of the wheel speed signals plus other signals which are on the bus. And it looks also very promising for wheel bearing, damages and unbalance. Yes, go ahead.
I've heard from someone that the tires, if you drive a car, I don't know which one, but if you drive it, you like talk or something. This is just something I've heard, that it's a signal coming from like the tire, sending that information to the car behind, and regulating the tire's pressure to address that bump on that exact spot. Is that just something I've heard from someone that you're doing, or?
We are not doing that, but you might have heard of from Mercedes the, what is it called, the magic right function or something. They have extremely expensive cameras in the front of the wheel, which are able to detect these potholes, for example, and then an extremely quick adjustable chassis, dampers and springs, so they can basically try to cancel out this pothole in real time. But as you can imagine, you need extremely good and extremely expensive cameras, extremely fast actuators, and a very good software in between coordinating this. So it's technically possible, but for some reason it has not gone in higher volumes yet. No surprise, it's extremely expensive. So we don't do that, but yeah, technically it's possible, you're right. But I mean, we rather go the other way. We make a map of the potholes, so you don't know, probably not with 1 meter resolution exactly where they are, but at least you know, okay, this is a bad road, and if I go with my Porsche 911, for example, with so much clearance, so much carbon, so much above the road, you don't want to go through that pothole. So probably you either take another route or you take it very cautiously. That's our approach. So yeah, condition monitoring and predictive maintenance. We think that is a topic which will become much more important in the future. I will also come back to that why. But well, I come from the traditional vehicle industry, automotive industry. And I don't know whether you have ever seen this. This is from the German Verband der deutschen Automobilindustrie. They have published some kind of standard development process. And most of the vehicle manufacturers, not only in Germany, all in Europe, Japan, the US, they more or less have applied the same scheme. And if you now look at this, I mean, I don't know, you're probably not familiar with all the terms there and all these gateways you have to pass and all that stuff. But if I look now with my 20 years experience at this, I immediately realize there's something missing. Can you guess what? Okay, let me help you. Software. It's all about production, hardware, purchasing, vehicle testing, materials, logistics, everything. No software. But have you ever heard of a term software-defined vehicle? This is something which is really a hot topic in the industry, because there are some newer vehicle manufacturers which basically do not have 500,000 employees doing since decades nothing else than creating hardware for a vehicle. For example, there's a specialized department with 20 engineers only designing front axles. They have done this 100 times and know exactly. They have highly sophisticated processes how to efficiently, safely, securely exactly do this. But then they need software for that. An operating system for a vehicle, like the Cariad, our own mother company. Okay, never done that before. It's not in the processes. Very, very difficult. But there are vehicle manufacturers who have not this tradition. Think of Tesla. They could design this from scratch. They could put software in the middle of the process, at the heart of everything, right from the start. So basically the hardware had to serve the purposes of the software, not vice versa. And they are quick. And the Chinese, for example, think BYD, NIO, Geely, these guys, they have completely different processes. And we see that because on the one hand, we have traditional automotive customers and also these, let's say, less traditional automotive customers, and they do it like this. Take this as 3 years, they do it in 1 year, if not quicker. And we call it, in many meetings internally, even with customers, we call it China speed. And this China speed is only possible with software. If you put the software at the heart of it and say innovation and a working vehicle is much more software than hardware. The hardware is serving the software, not vice versa. If you don't learn that, I think you will have, as a vehicle manufacturer or also as a supplier, you will have trouble in the future. And on the other hand, this is a huge opportunity for the guys here, for you guys. If you know how software works, they will need you. And these are some of the buzzwords I mentioned already. The software-defined vehicle. Anybody who has slightest idea what that is? Automotive data-driven business model. That's exactly what I said with the connected vehicles, which connect data. We generate maps for friction, road roughness, obstacles, whatever. Automotive data-driven business models. And that's also what the traditional vehicle manufacturers struggle with, to realize the value in this data and build business models which are completely data-driven. If you ask Google, that's their home turf from the start, or Meta, or whoever, they know that. But the traditional vehicle manufacturers, they have a problem with that. And of course, I mean, that's a buzzword, AI. But it, even in our domain, it plays a bigger and bigger role, because the analysis we do, or what we do with our input signals so far is predominantly algorithm-based. But we are putting a lot of effort also in investigating whether with AI tools, either for development or even as a function implemented in the vehicle or the backend, whether this could be an alternative to the algorithm approach. And that sounds very easy, over-the-air updates. Sounds like a small thing. I mean, that you can update the software in a vehicle while driving or when the vehicle is parked. But if you think about that from an engineering point of view, that is a complete game changer. If you regard software as a determining component of the vehicle, which determines its value and the customer value especially, then being able to go out with a preliminary function you offer, for example, for a selected circle of customers, saying, okay, we have a new test function. It's not perfect yet, but you can have it for free for 3 months, and you give it some feedback. You have it from tomorrow morning, just activate it and have fun. And then once the function is mature, you launch the final version, And then you may even get paid, and not paid 50 euros when the vehicle is sold, and then for the rest of the life it's for free. You could, for example, demand 5 euros per month over 10 years. That is much more money. And it also changes how do you develop vehicles. Yeah.
Sorry, we need to have the microphone so that everyone...
Yes. Well, I see your point with the sort of software-centered development, but I think isn't it also very important not to forget the mechanical design, because I think what we see now is that is what Tesla have done, that they have a 5-10-year-old car with their
Tesla.
and with their linkage and so on, braking and so it's so we need you mechanical engineers.
Thank you. As a mechanical engineer, I totally agree. And also, I like a perfectly tuned chassis and a really smooth and comfortable drive line, especially with an electric car. You're absolutely right. Yeah, but you give me basically the perfect transition to this slide here, because why do you buy a car or why do you not buy a car? And traditionally, if, for example, a car on the outside, and this is from a lemon car, as you would call it, from a Tesla, I mean, these parts do not really fit. The paint quality here is abysmal. But the thing is, most of the consumers, they don't care. I, as a specialized engineer, I go there and see, oh, there are the 0.2 of a millimeter gap here, that's not good quality. Most or an increasing number of people do not care, but they care about this. If they have, for example, an AI-based, speech-controlled assistant in the car, where you can tell, okay, show me on the display this, or activate this function, and it simply does that, and you don't have to repeat it 3 times, and sorry, we did not understand. If that works, and all these apps you have on your smartphone or the services you expect from home and from your computer work seamlessly in the car, that is a reason to buy a car. Or the absence of this is a reason not to buy a car. So this still is important, but it becomes less important.
But I think
yeah.
It's important it's not important for the first buyer, but what we see now is that dealers are very reluctant to trade in electric cars, some with
Yeah.
age, and people in general don't trust anymore the quality. They had paid $1 million for a car which they expected could last for tens of years, and after 5 years it must. So it's.
Yeah, you're exactly right. It probably got a little into oversteer in the one direction, and now it's oscillating back in the other direction, that people realize, okay, the second-hand value of these cars is probably not that good. And also for the vehicle manufacturers, it becomes more important. But I think it will stabilize with the focus more here and less there. And also, if I think, I mean, I was a chassis developer. If I think which effort they put into these small details and getting this noise 2 decibels down and that vibration and that the reaction time of the car to a certain steering angle is 1/10 of a second quicker, none of, I mean, not even I as a specialized engineer, I mean, I didn't admit it openly. I say, I don't feel any difference, sorry. And you put thousands of euros or crowns into the car to achieve this, and this is just for the experts. So I think customer orientation, and especially these functions, that's where the future plays. And this, as much as it hurts me as a mechanical engineer, especially as an automotive engineer specialized in chassis and drivetrain, as it hurts me, it's the future, I think. But let's see. Coming back a little to another big thing, or something which used to be a big thing in the last few years, that's, yeah, well, autonomous driving. You see the vehicles moving and this guy is sleeping like in an airplane. So would he really notice a strange sound from a loose wheel? Hardly. Or does he seem to care about the tread depth? Doesn't really look like it. Or the dampers? or even the tire pressure? Most likely not. That means even though the hype about autonomous driving has calmed down a little, it's something which is slowly coming anyway. And the thing is basically, the more autonomously you drive, the less attention you pay to the car. And especially the less it's your own car, you will not care. I mean, you know probably who Jeremy Clarkson is, and from Top Gear in England, this car magazine. He said a very wise sentence. He says the fastest cars in the world are rental cars. Why that? Because nobody cares whether they brake or not. They are just driven like hell. And that's exactly how people treat cars if they are not their own. That also means they drive different cars, car sharing. They rent a car or have a certain car only for the holiday period for 4 weeks. When they start driving this car, they have not the slightest clue how this car sounds and feels. So they don't care because they don't know that it's unusual. That means these cars need predictive maintenance. They need condition monitoring basically for all safety critical functions. And that's what we try to offer. And that is also extremely useful because these cars, they are not privately owned, they become commercial cars because they are owned by somebody who wants to earn money with them. So if the car breaks down unexpectedly, it becomes expensive. You need to send out a technician, you have to provide the user with another car and all that stuff. So what you want to know is, when will this car break, and can we have that, for example, this reparation with a regular service or something, can we put it together to maximize the available time, the money, the time the vehicle can earn money, to maximize that. And that's what we basically try to do. So I think with software in the car, automotive software, that is really, that's where the music is playing in the vehicle industry right now. And with that said, thank you for your time, and sleep well in your car in the near future, and well rested, that we make sure that nothing breaks in the meantime. Thank you.
Thank you very much. Do we have any questions? Yeah.
Hello, I was wondering, can you detect misalignment also for the car, for the predictive maintenance, especially for the wear and everything?
In principle, yes. If the misalignment is in a way that you, for example, have a certain force, as you have to counter steer all the time, then yes. Otherwise, probably not.
Okay.
Thank you. This was very good. I was wondering, are there any brands or manufacturers that are more like open as a platform so that other third-party developers can come in and build up the features on top of them?
Well, yeah, I mean, for example, Google, they offer their own automotive operative system, but vehicle manufacturers, of course, are a little afraid of going that way because they are afraid that Google is then taking advantage of the data and all that stuff, which is probably, that fear is justified. On the other hand, even the biggest vehicle manufacturers really efficiently can develop their own operative system. So for example, Volkswagen offer their MEB platform, or this operative system they have, and share it with other vehicle manufacturers also to have economies of scale. For example, also Renault, they have an operative system for compact electric vehicles, and they encourage also other vehicle manufacturers, come get it from us, and then we can develop it together. So the idea is there, but they still have, they are a little like rabbits. So I mean the big ones here, they are individualists, and in the mating season they have to fight first with each other to get their aggression level down. So they have to learn to cooperate, and that's basically the same also with the vehicle manufacturers. But I think sheer competitive pressure will force them to do that. Otherwise, they have no chance.
Yeah, maybe, sorry to follow up, like maybe some sort of API openness of some of these systems. So now we have this connectivity of the vehicles, and there are ways that you can like reverse engineer the API to talk to the car through the server. Like I know that for Hyundai you can do that, but have you seen anybody like openly offer that as a way to expand their sort of system?
I'm not that deep, not to my knowledge. I think this is going on, but that's also one of the big challenges, I guess. That if we are talking about mobile phones, I mean, if it shuts down for 30 seconds or is blocked or hangs itself, it's not a big deal. If you're going 180 on a German motorway and the car locks down for 30 seconds, it's a big deal. It's really dangerous. So you have to separate, let's say, the non-safety critical functions from the safety critical functions. And that is quite difficult. So I think most of the vehicle manufacturers have underestimated this challenge. On the one hand, the customer demanding all these connectivity functions, updates, and that. On the other hand, the safety relevance of all that stuff.
Yes, if we are talking about service intervals of cars, and if I look at the engine, so we went from a situation where we just look at mileage, and now it's a little on driving cycles and so forth, and so do you think, and that is related to sort of to how the oil is and how it's and these things, and could you how do you think the development or what is the development on that side? Are more parameters included, or is this good enough as we have it?
That is a very good question and a very big topic, I would say, because there are two fundamental attitudes from the vehicle manufacturer side. Some of them try to really generate these interactions with their customers. They see every repair or service opportunity as an opportunity to get into contact with their customers and earn money. Whereas and like myself, if I have to go to the workshop with my car, I regard it as a nuisance. That costs me, even if it doesn't cost me money because it's on guarantee or something it's included in the contract, it costs me time. I have to book a time, I have to be there. I don't like that. So, for example, like Tesla does it, if you have a small problem they can fix on the roadside, they just send you a car, ask you, do you need your car for an hour? Not, okay, we know where it is, we can open it, we can fix it, and then when you get to your car, everything's fine. Of course, that costs money, but it's extremely customer-oriented. But of course, they also, on the other hand, lose these interactions with their customers. So there's kind of tension. But you're right. Technically, with electrification, you actually, if you have good condition monitoring, you would not need a service interval. You basically would be in contact with a backend server and says, okay, you don't have engine oil. So you, for example, see, I don't know, the air filter for the AC needs to be changed. Because we have a differential pressure there, and maybe the windscreen wiper, the fluid has to be filled up, but that the customer can do it themselves. And otherwise, we have no trouble code, so no reason to call in that vehicle.
And of course, you want to have the interaction with the customer, but you want the customer to experience that positive, not to getting a huge bill.
Exactly. So you could, for example, approach the customer saying, well, for example, your filter here should be exchanged soon, so we can offer you, if you're interested, we can offer you a time, just drop by or something. So you can, with the connected cars, you could do this so much more convenient than just lighting a lamp and then leaving it to the customer, saying, now you have to contact a workshop, and they say, yeah, our next date is in 6 weeks or something. So terribly inconvenient. So you could do it much cleverer, I think. But that's only my personal opinion.
Yeah. If you want to ask your questions afterwards, it's just okay to catch him. Otherwise, I think we wrap this up. So I would like to thank you, Jörg, for presenting here today, and thank you to everyone listening and listening in online as well. And next Tech Tuesday will be held on the 7th of May, and this time it's going to be with SICK. The theme hasn't been announced yet, but you could mark the date in your calendars so you know when it is. And before you leave, I also want to highlight our next event that we're going to have here next week, where we invite you to an afternoon tea. And there, Savantic and Östgötatrafiken will talk about how IoT, Internet of Things, and AI can be used to work data-driven. And you could sign up for that at linköpingsciencepark.se, so you don't miss out on that. Yeah, thank you very much.